Today's lesson, we're going to take a look at how to predict what type of bond might form between two elements, but we're going to use electronegativity to do that. So the first thing that we need to go over again, just to review quickly, what is electronegativity? So this is a measure that shows an atom's ability to attract electrons, but specifically in a chemical bond. It's a numerical value. And it's a value that's referenced, so you can look that up on your periodic table. If you're looking at the one that we use in class, it's in the bottom right-hand corner. So how do you use electronegativity to predict what type of bond you have? You take the difference between electronegativity values for those elements. So we're shortening difference in electronegativity to using the delta sign here and E and N for electronegativity. So if, for example, you just had to calculate a difference in electronegativity, and let's say we do it for magnesium chloride, I would go to my periodic table, and the electronegativity value for magnesium, when I look that up, is 1.2, and my electronegativity for chlorine is 3.0. Then I want to take the difference in electronegativity, so I need to subtract the values. I always subtract the largest value from the smallest. So I do 3 minus 1.2, and it gives me 1.8. That's my electronegativity difference. So if you're asked to do that calculation, that's all you have to do. Look up your values on the periodic table, subtract them, and you get a number. And as we go through the rest of the lesson, this number here will match up with a specific bond type. Now, one other thing to note, you might have noticed there's one magnesium and two chlorines here. We don't multiply, though, any of these numbers by the number of atoms. Magnesium is bound to chlorine 2 different times. We just want to see the difference between a chlorine and a magnesium. Don't worry about how many you have in your formula. So we're first going to look at how do we use electronegativity values to figure out what type of covalent bonds you have. There's 2 types of covalent bonds. One is a nonpolar covalent bond, and the other is a polar covalent bond. So first, we'll go over what it actually means to be a nonpolar covalent bond. This happens when atoms that have identical electronegativities share electrons, or you can say the difference in electronegativity is equal to 0. So if we did it, for example, for hydrogen, if we remember our Lewis diagrams for hydrogen, hydrogen gas would be H2, so it would look like this, or if we replace it with a line for our bond, it would look like that. One hydrogen shares one electron, one hydrogen shares the other electron. Both of them have a value of 2.1 when you look them up on the periodic table for electronegativity difference. So when you do your electronegativity calculation, 2.1 minus 2.1, it's 0. From a sharing point of view, here everything is shared equally. All of those electrons have equal sharing. There is another type of covalent bond, as we mentioned, and this one is called a polar covalent bond. Now this one's a little bit different because the sharing isn't exactly the same. So what happens? Electrons in this case, they're shared between atoms, but their atoms have very different electronegativities. If the difference in electronegativity is less than 1.7, it's considered a polar covalent bond. And what happens here is it causes a bit of a charge to form, a slight positive and a negative charge in the molecule. So let's walk through an example together so you can see what's going on. If we were to draw out a Lewis structure for HCl, hydrogen shares one, the other one's from the chlorine. Or if we draw it like we were practicing in our last lesson, it would look something like this. So let's look up the electronegativity values. Chlorine is 3.0 and hydrogen is 2.1. So here, if we're calculating electronegativity difference, we're taking 3 minus 2.1 and we get 0.9. So that definitely falls within our range here, less than 1.7. What this means is electrons are shared, but they're not shared equally. So how can we show this? There is a little trick we can use with the electronegativity values. So to do that, for reference, I'm going to write down here my electronegativity values. And I can see that chlorine has a higher electronegativity. So that means it likes electrons more than hydrogen in the chemical bond. So chlorine, you can see it already has lots of electrons. It's going to pull the ones that are in the bond in the middle here towards it. So what we do is put on something called a dipole to show this happening. So I take my arrow and I point it towards the chlorine. This end over here is going to end up being positively charged because it's lacking electrons. And over here, it's going to end up being negatively charged because the electrons get pulled towards it. That's why we see this plus sign over here to try and show this end has a little bit of positive. This is called a dipole. So we can draw these on where bonds are not equally shared. This end here will end up with a partial negative charge. Because it clusters the electrons around, and we know electrons are negative. And this end over here is a partial positive charge. Because it's all of a sudden losing electrons, it's being pulled that way. To show that the other option instead of a dipole, sometimes you see a lowercase delta. So it looks like this, almost like a figure 8, except you stop, and then it puts a little positive charge. Same thing over here, or negative. So the lowercase delta is saying partial positive or partial negative. There's one more type of bond, which we already have learned about, which is the ionic bond. But we haven't talked necessarily about it with electronegativity. So we know in an ionic bond, electrons are transferred between atoms. Remember, the metal gives away the electrons to the nonmetal. And when you look at their electronegativities, they're very, very different. We say even significantly different. So their values tend to be about 1.7 or higher. So if we did the same thing for sodium chloride here, sodium chloride, we'd want to look up its electronegativity difference. Chlorine's electronegativity value is 3. When you go on your periodic table for sodium, it is 0.9. So here, if we're looking at the difference, 3 minus 0.9 is 2.1, and that definitely falls within that range. Sometimes, though, there are some exceptions. Ionic bonds are actually a little bit less than 1.7, but the way you can always tell is, remember, ionic is going to be between a metal and your nonmetal. So putting all of this together, we can look at something called the electronegativity scale. And we can try and rank or look at what the differences are for electronegativity values. So if your electronegativity difference is approximately 1.7 to 3.3, you end up with an ionic bond. Anything less than 1.7, when you have 2 or more nonmetals, you've got your covalent bonds. If it falls between 1.7 and 1.5, we call it a polar covalent bond. If it's less than 0.5, we say it's slightly polar covalent, but very weak. And down here where you have 0 or no electronegativity difference, that's where your polar covalent bond comes in. This area from here going down shows what happens with electrons and sharing, that it changes. So here up on this end, they're not shared equally, and down here you have completely equal sharing. So it's kind of like a gradient. Not sharing very well, starting to share a little bit, starting to share more, almost equally sharing. And once you get to 0, everything is shared exactly the same. So let's try out a couple of examples to see if you can figure out what type of bond might form. So first example, what type of bond will form between these 3 atoms? So you should pause your video and see if you can figure out what type of bond you'll have between carbon and fluorine, iron and oxygen, and chlorine and chlorine. And you want to use your electronegativity values from the periodic table. So take a minute, pause it, and when you're ready to check, we'll keep going through the answer together. All right, so now we're back. We're going to look at electronegativity differences. So when we look at electronegativity differences, fluorine has a value of 4 and carbon has a value of 2.5. So if I do that, take my difference, I get an electronegativity difference of 1.5. 1.5, when I go back up and have a look, 1.5 falls in the polar covalent range. So I know I have a polar covalent bond. Next, let's take a look at iron and oxygen. So oxygen, its electronegativity difference is 3.5 and iron is 1.8. So here we're going to subtract. And you get 1.7. Now if you remember, 1.7 is kind of like that midpoint here. So what happens if it is exactly 1.7? Then you're going to look at what type of elements you have. Ionic is a metal and a nonmetal, and polar covalent are 2 nonmetals. So down here I see iron is a metal, oxygen is a nonmetal, so this means I have an ionic bond. Last one. What about chlorine and chlorine? Here right away, you shouldn't even have to do your difference to know what type it will be. They both have the same electronegativity value of 3. So when you do your difference here, you know it's going to be 0. and that means you have a nonpolar covalent bond. All right, let's try out one more problem and see how it goes. This question says, arrange the bonds in the group below in order of increasing polarity. So increasing polarity means from least to most in terms of electronegativity difference. More difference means more electronegativity. So to answer this question, what you want to do is find out what the electronegativity difference is for each of these each of these four pairs of pairs of atoms and how they share electrons. So at this point, what I would do, pause your video, see if you can calculate the electronegativity difference, and then rank them from most to least. All right, let's check back here. So electronegativity value for hydrogen and chlorine, 3 minus 2.1 should give you 0.9. Oxygen and nitrogen, 3.5 minus 3 gives you 0.5. Carbon and sulfur are about the same. They're both 2.5. So 0. And then sodium and chlorine. So now if I want to rank them, the highest will be the most and the lowest will be the least. So increasing polarity, number 1 here is going to be the least. Next lowest number here between oxygen and nitrogen. Then it comes hydrogen and chlorine. And the last one's ionic. It has the most. So hopefully now you can see how you can use electronegativity to look at how electrons are shared between two atoms with a numerical number and how you can use that value to determine bond type.